Welcome back. So last video we finished up factoring. Now we're going to go ahead and move on to fractions. And this one is pretty important, especially when it comes to calculus. A lot of people think they struggle with calculus, but it's really stuff like fractions that just slow them down. And it's not really that hard. It's just been a while since you've seen it. So we're going to go ahead and do a quick little reset. We'll start simple, then build up, and by the end we'll do some problems that actually show up in calculus. So we'll go ahead and start up with simplifying. When we're given something like this, 2x over 4x, we're keep it simple. You're just canceling common factors out. So we go ahead and cross out the x's on both sides, which just leave us 2 over 4, which just becomes 1/2. That's simple. Now, some people do tend to make a mistake here. Not with this specific problem, but with another problem that I'll write down here. We'll do x plus 2 over x. People tend to cancel out the x's here and then say that they got 2, but we can't do this. This is a big no. This will lead to a lot of bad things. You can't cancel across addition. That's one of the biggest mistakes that a lot of people do, and we'll go ahead and move on. Adding fractions is pretty important as well. I'll give you an example here. 1 over x plus 1 over x plus 1. All right, Mr. Duck is in the way. So with this is where things, start to get a little bit more difficult, but not really. I promise. Whenever you add fractions, you do need a common denominator. So both of these need to be looking the same. So what can we do? We can go ahead and just multiply both of them. This is the exact same thing here. So how I got that was we basically went ahead and just added these up together, but still having the same common denominator. X plus 1 on top, right here. X being on top, right here. That's all I did. And we can go ahead and further simplify this as well by going ahead and adding these up together. So we're going to go ahead and add up the x's, which gives us 2x plus 1, still having the same common denominator, x plus 1. That's it. And this is the exact structure that shows up all the time in calculus as well. Next, we're going to go ahead and move on to multiplying and dividing. So let's say I give you 1 over x divided by 2 over x. Now you can go ahead and write this differently by 1 over x over 2 over x. And basically what we can do here is we need to flip this around and then putting it right next to it. So we'll go ahead and do that. I flip it around, we get x over 2, and then I add it right next to it. We're multiplying, which gives us 1 over x times x over 2. That's it. Division is easy. Just flip it and multiply it, which we can go ahead. X over 2x. The x's cancel out, which just gives us 1 over half. That's it. Really simple. Don't overthink it. Now we're going to go ahead and move on to something else. Complex fractions. This one does look a little bit scary, but I promise it's not that bad. So the method with this one, we basically have to multiply everything by x. We see that this is x, so multiply both sides by x, which we can do because x over x is just 1. So if we do that, this x cancels out, this x cancels out. And then this x moves over here. Don't forget that part. So we get 1 plus x over 1, which is just x plus 1. That's it. Whenever you see fractions inside fractions, multiply through to clean it up. Not that bad. Now let's go ahead and move on to something a little bit more harder. So with this one, we can really just focus on the top. That one really doesn't do anything for us. We get 1 over x over 1 over x plus 1. So now adding or subtracting fractions. So now I need a common denominator. The common denominator, we multiply both of these together, Mr. Duck, uh, which then goes ahead and gives us x plus 1. That's our common denominator here. And if we really wanted to, we would just do the butterfly method here, giving us x plus 1. Put this on top, put the x on the other side, but we gotta have our common denominator first. So x times x plus 1 minus x over x plus 1. That's it. We can go ahead and combine this a little bit more. Gives us x plus 1 minus x, same common denominator, x times x plus 1. That's it, Mr. Duck. And we can just cross these out. Just gives us 1. Oh, Mr. Duck passed away. X times x plus 1. That's it. The x's cancel out with the negative x, so I'm just left with 1, and this will be our final answer. So now let's go ahead and do something else that kind of puts everything together. This one is kind of the big one, um, but it's really easy. This looks like a fraction problem, but it's also a factoring problem. I went ahead and added our equation from our last video up here, which states a squared plus b squared is the same as a minus b times a plus b. So we can go ahead and do the exact same thing here. Let's go ahead and focus on the top first. X squared minus 1. Using this equation here, this is basically already squared, it's just 1. We can do x minus 1, x plus 1. That's it. Now let's focus on the bottom here. X squared plus x. Now this, you actually do what we learned here before about the greatest common denominator here. So we can go ahead and factor out an x outside of this. So the x comes out, the x cross, we can think about dividing by x, like our last video. X is crossed out, this crosses out, but x over x is just 1. So we get x times x plus 1. That's it. Now I can go ahead and rewrite this. X minus 1, x plus 1, divided x plus 1. Perfect. This is exactly what we need. Now this is what we can do with this. Do you remember in the previous one, we were able to go ahead and cancel it out? We can go ahead and do the same with this because it's multiplied. It's not adding. It is not this example. If it's x plus 2, we can't cross out the x's, but it's not. It's multiplying. And I'm looking at this thing specifically here, x plus 1, since we have both it in the numerator and the denominator. So we can go ahead and cross both of these out. That's it. Which then leaves us with x plus 1 over x. Sorry, x minus 1 over x. And that's it. We cannot cancel out these x's. That's the same mistake from the very first problem. So this is it. All right, that's basically it. Don't rush fractions. Always find a common denominator. Don't cancel across addition. Use factoring when needed and clean things up step by step. If you get this down, limits become way easier. In the next video, we're going to go ahead and get into radicals, irrational expressions. This is where things start to look a little bit ugly, but it's not a problem. I'll walk you through it step by step. So if this video helped you in any way, please like it and please subscribe. Thank you. I'll see you in the next one.